I'm Anil Kumar, sharing with you an application question from my student's test paper. The question is, an environmental study suggests that the average daily level of carbon monoxide in the air may be modeled by the formula C of P equals to square root of zero point 0.5 P square plus 17 parts per million when the population is P thousand. It is estimated that T years from now, the population of the community will be P of T equals to 3.1 plus 0.1 T square, 1000. So population is in thousands. At what rate will the carbon monoxide level be changing with respect to time 3 years from now? You can always pause the video, answer the question, and then look into my suggestions. So let's see what we need to find. It says, at what rate will the carbon monoxide level, that is the level, be changing with respect to time? That means derivative of C of P with respect to time 3 years from now. So when T equals to 3, this is what we need to figure out, right? So at T equals to 3, we can also calculate what the population will be. So we can write what is P of 3 equals to. This population is in thousands, right? So we get 3.1 plus 0.1 times 3 square, which is 3.1 plus 0.9. 3 squared is 9. 9 times 0.1 or 4.0. 4,000, right? So that's the value at T equals to 3. So let's begin by finding the derivative of the function itself. So we are given the function with respect to population growth 0.5 P square plus 17, right? So if I differentiate this with respect to time, I get dCP over dt equal to square root function is 1 over 2 square root of all this, right? 0.5 P square plus 17 times derivative of inside function. So we get 0.5 times 2 is 1, rather P will get here then, P. So that is the derivative of inside function, right? 2 times 0.5 is 1, so we get P. Times, since this is P, we get dP dt. Right? We are differentiating with respect to time. Now, population P of T is given to us. We can always find what dP dt is. So let's figure that out also. So let's do it here. Population is equals to 3.1 plus 0.1 T square. So dP dt, this is a constant, we get 0.2 T, right? So dP dt is 0.2 T, which can be placed here. At this time, since we are interested in finding population at T equals to 3, let us substitute T as 3, right? And P is 4.0 to find the change in carbon dioxide level after 3 years, right? So let's put this as T equals to 3. And replacing P with 4, we get here P with 4, we get 4 divided by 2 times square root of 0.5, 4 square plus 17, right? Times dP dt, which is 0.2 T, right? So we can also find here dP dt when T equals to 3 will be 0.2 times 3, which is equals to 0.6. So I'll replace dP dt with 0.6. Is that okay? I'm doing it since I have very limited space. Otherwise, I should have written one more step here, right? So I'm writing 0.6. We'll multiply by 0.6. Correct? So that becomes your answer. You can always calculate this answer to write down the rate of change, right? So in this case, our units will be rate of change of population, rate of change of carbon monoxide, which is parts per million, with year, right? So the answer will be parts per million per year. So let's calculate this. 4 can be divided by 2, we get 2. So the numerator will be 2 times 1.6, which is 0.6, which is 0.2, and square root will be 16, half is 8, plus 17, right? Which is 1.2 over, that is 25, so square root will be 5, right? So you could always divide this by 5 to get the answer, which is 0.12 is 2, and then 0.24, and the units will be parts per million per year. So that becomes the solution for the given question. So the idea is we have to apply the chain rule to find derivative of the carbon monoxide levels with respect to time. So the population is given in terms of population is given in terms of time. So therefore we have a chain rule. We have a function of function. So I hope this method helps you to understand how to apply chain rule wherever we have functions or functions to work with. Feel free to post your suggestions, share my videos, and post questions. Thank you and all the best.